Imagine looking up at the night sky and realizing that somewhere out there, right now, a star is being born. And I mean right now. And for the first time in human history, we've actually seen it happen, thanks to the James Webb Space Telescope. Recently, Webb looked deep into a region called the W51 molecular cloud, a massive stellar nursery buried inside our galaxy, and what it found was chaos. There were dense clouds of gas collapsing, sending shockwaves rippling through space, and all when baby stars were in the process of forming. This is stellar construction in real time. Now, here's a problem. Stars form inside thick clouds of dust that block visible light. So the telescopes like the Hubble telescope can see basically nothing. But James Webb telescope, it can see in infrared. That means it can see through the dust like night vision for the universe. And suddenly, what used to be hidden is now completely exposed. Inside W51, the telescope captured gas collapsing under its gravity, protostars actively feeding on surrounding material, jets of plasma shooting out at insane speeds, and turbulence shaping entire regions of space. It was a violent, unstable, and unbelievably energetic thing. It was less like a birth but more like a cosmic storm which formed the star. So how does this chaos turn into something as stable as our sun? Let's break the physics down. So here's where we start, a giant molecular cloud. These are massive clouds of hydrogen gas, which are around 10 to 100 light years wide, and they're extremely cold, around 10 Kelvin. The gravity versus pressure here is roughly balanced. And now we go to the trigger events. These can be something like nearby supernova, galactic collisions, or shockwaves. These disturb the cloud, and then the collapse of the star begins. Regions of higher density collapse first. This is governed by the gene's instability. As the gas falls inward, gravitational potential energy turns into heat and the temperature rises. This is how the dense core of the star forms. Now we move to the protostar phase. A protostar forms at the center. This star is still gaining mass from the surrounding gas, which is called accretion. This leads to the formation of accretion disks. Then the magnetic fields channel material into jets. Then the radiation pressure starts pushing outward. And this was exactly what James Webb was observing. Now we move to hydrostatic equilibrium. When the gravity is pulling inward and the pressure is pushing outwards, the system stabilizes and the star stops collapsing. Then we move to nuclear fusion ignition. Once the core temperature hits around 10 million Kelvin, the hydrogen nuclei fuse and turn into helium. And this is governed by the mass energy equation E equals mc squared. A tiny amount of mass becomes a huge amount of energy. And now the star is officially on the main sequence. Now finally, a star is born. This star has a stable energy output, a long-term equilibrium, and begins its life cycle, like our sun. And this is why the James Webb Telescope changes everything. Before the James Webb Telescope, the star formation was mostly simulations and indirect evidence. But now we can directly observe accretion, jets, turbulence in early stage stars. Now it's the difference between guessing how something works and watching it happen. And with the James Webb Space Telescope, we're finally watching the universe build stars. And it's pretty beautiful. If you guys enjoyed this video, make sure to like and subscribe. Be curious like a child, the world needs more of it. Bye!